Hey everybody, we're going to go ahead and get started. This is track 2 from 11:20 to 1 p.m. and we have an exciting lineup of speakers. I don't think there's a track 2 title, but it's generally printed electronics. And to start off with, we have Momentive and BSC with John and Andreas. And I'll go ahead and hand it off to them.
Thanks, Eric. So welcome to this session, Sustainable Motion. And we are in the track of printed electronics. And what I show is, you might be a little annoyed, it's not a printed electronics, but a very, very cool technology. And I start with a picture with some you people might know or have at home. But I wanted to start with, there is several ways of how to translate energy into motion. And about 250, 300 years ago, somebody invented the steam engine. That's, of course, not a very sustainable way today of creating motion. There is more other different ways, and of course, it's not fair to compare a steam engine which generates kilonewton, megawatt with something which is based on silicone. But if you think of IoT devices which generate motion, it is not a way to use big engines or motors or whatever in order to create this engine, this motion. So we start with a short physics lesson. If you have two attract plates, and you might remember in your youth having an air balloon rubbing on your sweater, and then what happens if you put it over your hair? What happens? It attracts the hair, or you can put the balloon to the ceiling. So if you have charge plates, then those plates attract each other. So this is a way to create motion out of electricity. And if you do that on a scale, you build literally a capacitor, then you can create a dielectric elastomer actuator, which is plates which attract each other when applying a high voltage, and there is a material in between which is based on silicone. This is what we do, and we have decided in a small ecosystem. It's not a big ecosystem like the other presenter this morning showed with NextFlex. It's a small ecosystem. It's 3 companies who are joining forces in order to bring this technology to market. And those 3 companies are Momentive, Dielectric, and BSC, where I'm from. My name is Andreas Schneider, and hand over to Jan from Momentive.
Thank you, Andy. Good morning, everyone. So, my name is Jan Geboers. I lead the application development teams for silicon elastomers in EMEA and India for Momentive. And like Andy said, there's a small ecosystem of companies that are partnering up to bring this new application in a scalable way into the market. So that's Momentive. We've developed and we're supplying the silicon material that makes up 95% of the actuator. There's BSC that is driving it with the right type of electricity, of power structure. And then there's Dielectric. Don't miss their talk tomorrow in track 1 at 12 p.m. They're going to talk about the stack itself, about the actuator itself. I am by far the least interesting person in this triumvirate. I'm going to talk about the silicon rubber real quick, just to help you understand why silicon rubbers can be a very interesting material for an application like this. And maybe get a few of you also interested in silicon rubbers in a broader sense. Silicon rubbers are widely used in a very wide range of applications. It's truly mind-blowing. I've been doing this work for over 12 years, and still I find new applications. But the ones that are relevant today, because they exhibit or they showcase some of the advantages of silicons in a way that also translate into these actuators, are high voltage insulators, healthcare, and automotive. And if we're going to talk a little bit about high voltage insulators here, silicons are prized for their excellent dielectric properties. So obviously there's a big advantage there also in using them in actuators, which are basically capacitor plates. You can make them either very strongly insulating, 4.5 kV and more, or highly conductive, and all with the same type of base material, just depends on the additives that we use to formulate them. And they